All right. Thank you so much. Thank you, everybody, for joining us here today. I hope that this ends up being a helpful tutorial for you guys, especially creating capsules and making algorithms and understanding how BrainFrame works. So today's presentation is going to be focused on the following things. So what I'm going to try to teach you is how to make a capsule in BrainFrame, how to compile the capsule, kind of show why these capsules are so easy to make, and then show how this might interact with models from different frameworks such as TensorFlow and OpenVINO. And so I'm going to start off with explaining just what the capsule system is to make sure that everybody's on the same page. So the capsule system, the idea with capsules is that we can easily plug and play algorithms into an existing video analytics framework. And what we're trying to solve is a couple things. The first thing is we want to abstract algorithms from the hardware that they're running on. So if you have one GPU, 3 GPUs, or no GPUs, that should be invisible to the user. Capsules should be able to solve that problem for users. And the second thing we're trying to solve is easily being able to have existing machine learning algorithms and add a new one into the mix without having to change the existing algorithms. So for example, if you have a very good person extractor that can find people in videos, and you make a new algorithm that can tell you what kind of clothing that person is wearing, it should be easy to combine these two algorithms so that you can detect with one algorithm and classify with the other. And so that's what capsules allow you to do. And so the reason this is so powerful is now with one video analytics system, such as BrainFrame, you can identify different problems, such as, here we have a couple examples, like in a store, finding out how long someone has been waiting at the checkout line, or in construction sites, seeing if workers are wearing their safety helmets, making sure people are washing their hands in restaurants. So you have to find whatever problem you want to solve, and then instead of programming your own video analytics system, you just make the capsules or select existing capsules that will help you get that information from the video. And then BrainFrame will take all of that data from the capsules, save it onto a database, expose it through a REST API, and generally make it more useful for you. So by making a single capsule, you have this entire system that can provide value onto the data that you're extracting from this video. And so where capsules fit inside of the BrainFrame architecture? So a brief overview of the BrainFrame architecture is you have the server here. Video streams get connected into the server. BrainFrame will handle processing the video. Then each frame gets fed into each individual capsule. Now this is where BrainFrame handles all of the scheduling of the algorithms. So BrainFrame will very optimized handle inference for you across one video stream to 100 video streams, and it will handle multiple capsules and running them in the most optimal way possible. The data from these capsules is routed into two places. The first is to the REST API. So you can immediately get access to the inference data from these capsules. And the second place is to our database. So everything gets recorded in a way that you can then query for it in a dashboard. So the benefit that BrainFrame is providing is the video extraction, the client, the API, the recording of data, the displaying of data, and this environment with the capsules that makes it easy for developers to make their own algorithms. Think of capsules as apps for Android. They are self-contained, and they contain the libraries that they need to run on, and they plug into a larger architecture that takes care of the interactions between the apps. So most of this presentation is going to be about actually making these capsules. So the first thing I'm going to do is I'm going to ask that anybody who has any questions, please put them in the chat. And Yi, or Zhao, if you could tell me when someone has a question so I can stop immediately and try to answer the question. So I'm going to start out by showing how to set up your capsule environment. And one moment. So the first thing you're going to want to do is install the capsule libraries. So OpenVision Capsules is it's free and open source. So these are publicly available on our GitHub under the OpenCV GitHub. So you can actually go to github.com/OpenCV and take a look at the Vision Capsules code. So I'm going to show you that. And so this is the OpenCV repository here. And so this code base defines the structure of how to make a capsule and how to wrap your existing machine learning models in a capsule. So we're going to install from PyPI the libraries for this, and we're going to clone a couple open source capsules. So I'm going to go ahead and do those steps here before continuing onwards. So here we have, we're just pip installing the libraries that we need. So VCap is the Vision Capsules main library, and VCap utils is sort of a collection of very helpful wrappers around different frameworks that allow you to load their algorithms much easier. So for example, VCap utils makes it easy to load a TensorFlow model into a capsule, or it makes it easy to load an OpenVINO model and turn that into a capsule. So before we get going, I want to get a BrainFrame server running here. So we're going to go ahead and download a BrainFrame server from the website. And everything I do here, I'm just going to download the Docker Compose for the BrainFrame server. I'm going to download the client for the BrainFrame server. And make sure that you have a license ready. So here's the Docker Compose. So just Docker Compose down, Docker Compose up. And so this will start and set up your BrainFrame server. So while that runs, I'm going to drag in the client. So here's the latest version of the client. Great, so we can see the server is running now. And I have the client open. So I don't have any videos, so let's go ahead and populate this with some videos. And maybe something with some people and faces. Oops, that does not exist. There we go. So we have a couple videos running, and you can see here under global plugin configuration that we don't have any plugins yet. So everything we do today, we're going to be building them, but it might be easier to just get started with an existing capsule just to show you how the system works again. So we're back to here. This is where the Docker Compose is, and we want to download a capsule and drag it into here. So I'm going to go back to our downloads and download just a person detector, something so that we can see some results here. Yeah, this is good. I'll just drag that in there. And we'll wait for that to load into BrainFrame. So when you drag a capsule into BrainFrame, the first thing it does is it looks at the devices that that capsule is supposed to load onto. So for example, the capsule I just loaded loads onto GPUs. And so it loaded onto my GPU on my machine. And now you can see the different results that it's outputting. So we have 2 videos. We have some capsules loaded here. Now it's time to actually start developing a capsule. So I installed the libraries, but now I want to actually get some open source capsules. So I recommend cloning our open source capsules repository. So I'm going to do that here. Let me make sure you can see this. And so make sure you have git LFS for this, because we use large files storage to store our models. So what you'll find inside of this repository is a list of different open source capsules. So these down here, these are the capsules that are loaded onto the server right now. And over here, these are unpackaged capsules. So you know that a capsule is packaged when it is a single file. It's got the .cap there. These are just directories with different files in them that make up the capsule. So at this point, I think it's worth talking about what exactly makes up a capsule. So the very first thing is the actual structure of the files. So in order to have a capsule, you only need 2 files. A meta file, which contains the API version for that capsule. That way BrainFrame can check to make sure that it's compatible with this version of the capsule spec. And the second thing that BrainFrame will look for is a capsule.py. So it will search for a Python file called capsule.py and run it, and then extract a object called capsule. So let's go ahead and let's build this structure here. And for this first example, I'm just going to make a fake capsule. This is not a real capsule. It's not going to do anything very impressive, but it's just going to show all the different features of the capsules system. So right inside of BrainFrame's capsules repository here, I'm going to make something called, my PyCharm window has frozen. Great. Okay, let's go ahead and, so since this is frozen, I'll just go ahead and do it in my file manager here. So under capsules, I'm going to make a directory called basic capsule. And so this is the directory that has the files and everything that is going to be packaged into the capsule. And inside of here, I'm going to create the meta.conf. And I'm going to create the capsule.py. So right now these are empty. So let's go back to editing them on here. There we go. Okay. So inside of the meta.conf, you need to fill in the API version that you're going to be compatible with. So in our case, it's going to be under the About section, and it's going to be API compatibility version 0. So actually, this is 0.1. Yeah, that's the version of the VCap library. So you can actually check what version of the VCap library you're running. So we're running 0.1.3. So you only have to match the major and the minor version. Great. And so for the capsule.py, this is where things get interesting. So let's go ahead and look a little bit. What goes inside of the capsule.py? So what BrainFrame does is it looks for a class called capsule, and this should subclass base capsule. And so this class, there's a it's sort of like a combination of different callbacks. So BrainFrame will call back different functions as it needs it. But the first 3 lines here are mostly just describing the capsule basic features, right? So what's the name of the capsule? So the name of the capsule is what shows up here, right? What's the description of the capsule? And that's what shows up here. And then the version of the capsule, which you currently can't see on this UI, but is still used with BrainFrame to make sure that it's running the latest version of the capsule. And so if you make a capsule with the same name and you change the model, you could bump this version up. Right? So that's the main kind of just basic descriptors. Then we get into the more interesting side of things. So BrainFrame is capable of connecting different capsules. And by that I mean, I gave this example earlier, but again, let's just say you have these cars being detected, and you have a capsule that can output vehicle detections. And you want to have another capsule that can classify the color of the vehicles. Now, this second capsule is not able to find vehicles, but given the location of a vehicle, it can tell you the color. And so this is entirely possible with BrainFrame to have capsules that do different things and require different inputs. And so in this example here, we have a capsule that requires no input. So this says none. The size is none. So we're saying this capsule doesn't need any input from another capsule. And then the output type, this is where we tell BrainFrame what to expect from our capsule. And so here's where we describe what the data type is going to be. So all implies that it's going to find all objects of a certain type. And these detections are the class names. So in this example, I'm going to be creating a capsule that just puts a box on the top left of the video. And it's going to be of the type example bounding box. And so, for example, for this capsule, it would return a detection of type person. So I hope this all makes sense so far. So moving on. Now the last thing you can do with capsules is you can configure them. So here you can create different options, and these options will be set by the user in this interface. So here you can see I can change different numbers, I can tweak things, I can create drop downs. And so this is all specified under the options section of the capsule. And so there are different options you can import. And so all you have to do is put the name of the option and then the values. So for example, here's the threshold, and you can see the description of the value, and then you can edit it here. And you can specify the default value. So for here I have 0.5 and a minimum value. So for example, let's say I tried to put, I can't put a negative number here. Let's say I tried to make a larger number than 1. It won't let me apply. Right? So I have to put 1 or under, and then it will let me apply. So that's the very beginnings. So let's go ahead and let's build that here. So here I have a capsule, and so I'm going to start by making this exact structure. So from vcap, I'm going to be importing different things from here. So I'm going to start by importing base capsule. And so you have to name your capsule class capsule so that BrainFrame knows how to find it. And so let's give it a name. So I'm going to call it fake bounding box detector. And we're going to give it a description. And so this is a fake detector that outputs a single bounding box. And then we're going to, this is version 1 of our capsule. And so for the input type, So this capsule doesn't need input from another capsule. So we're going to do what we did in the example there. So in order to specify input types, you need to have an object called node description. And so you can see here a little bit more about node description and take a look at the documentation since it's all open source. But in our case, we just need to do something pretty simple here. So we just need to specify the input type is going to be a node description. So the size is of type none. So we don't need an input. We don't need anything from BrainFrame here. Let's just put that on one line. And the output type, and so this is where we describe to BrainFrame what is this going to output. What exactly is this capsule going to output? So I'm just going to leave this with some question marks until we get to the backend. And so on the backend side, so I'll bring that up in just a moment. So we have to have a backend loader, and so this is I'm just going to leave that blank, and then the configurable options, and so I'm just going to leave those empty. So far we have kind of a rough outline of what the capsule is going to look like, but we're missing some critical components here, right? We need to fill this up, we need to fill this up. And so let's get started. So what is a backend? What does that mean? So the backend is where inference is supposed to happen. So if your capsule specifies to BrainFrame using our advanced features that it needs to be loaded onto every GPU on a machine, BrainFrame will instantiate a backend object for every GPU on that machine. By default, it will load a backend onto a single CPU, so it'll load it once. And so these are the functions that BrainFrame expects to find on the backend. So the first is the process frame function. And so what this does is it passes you the video frame for this particular instance in time. It will pass you any inputs that your capsule expects. So if this was a vehicle color classifier, we would get the vehicle detection here. So we would know where the location of the vehicle is relative to everything else in the frame. This is where the capsule options get fed to you. So these options that we specified here will appear here with all of the user settings set, or the defaults. And the state, we're not going to cover that today, but that's if you need to save variables in between different frames. So that's where you would specify, that's where BrainFrame would feed you the stream state. And so what process frame expects from you is an object or a list of objects called detection nodes. And so detection nodes, this is our way of describing all of these bounding boxes with their names and their types and their face recognitions and their track IDs. All of this information gets put onto a detection node. And so here we have a name for the detection node, which is going to be an example bounding box, and we have the coordinates. So the coordinates is an arbitrarily long polygon. So you might have thought that we only supported bounding boxes, but we actually support any shape that you want. You just have to specify the coordinates. And so in this case, this will draw something at 1010, which would be the top of the screen, to 110, to 100, 100, to 1010, and then it'll come back around. So it'll go like that. Now, how do I clear this? Is the real question. Great. And so then we have these other options here, such as batch predict and close. And so these are, batch predict is what you would use if you have a GPU enabled model that benefits from batching. And so for those who don't know, batching is the process of taking more than one image and sending it to the GPU in one go. And the benefit of that is you can get, sometimes 2 times speed up, maybe even 3 times the speed if you are batching properly. And so if your model and your framework is capable of doing batch processing, you would want to do any batched processing here. And so you can send images to be batched inside of your process frame, receive them here, do batch processing, return the results, and receive them back here for anything else. And so this is getting a little bit advanced, but you can always check out how we implement these things on our open source capsules. But I'm not going to touch batch processing today. But let's go ahead and build the backend for our basic capsule. So the first thing we need to do is we need to pull the base backend object here. So class backend, base backend, right? And so the backend is created by this function. So we can actually make any kind of function that goes here and returns a backend. BrainFrame just expects to be able to feed you the files inside of the capsule and then into this function, and you will return back to BrainFrame the loaded capsule. So in this case, the function takes in capsule files and a device. And so this is where you would receive the GPU device that your capsule should run on. So this would be the name of the GPU or a Movidius device or whatever inferencing chip that you expect. And that way your capsule or your backend. Yeah, go ahead. Yeah, how is this? Okay, might not be able to fit everything on one page. Here, let's see here. Yeah, no problem. So where was I? Right, so this is supposed to be a function that takes in the files of the capsule, the device that the capsule should load onto, and returns a backend. So in this case, our backend doesn't use a GPU or anything, so we don't really care about it. And we don't use any of the files within the capsule. But if we wanted to, and let's just, in this case, let's just do an example where we do. We would specify here in the backend that we need the capsule files and the device. And so here, I'll just put a print here. And then we'll call these super. So according to here, we need to have a process frame, a batch predict, and a close function. So I'm just going to copy those over to here. So so these are the three functions that you need to run a backend. So for every frame, for every stream, BrainFrame will run this function. And we will receive a frame, and for this, we will receive nothing. We will receive none. And the reason for that is because we specified as our input type none. Does that make sense? So BrainFrame will run process frame, and it won't give us an input. And that's because we specified to BrainFrame that we don't need an input. But let's say, for example, that we had specified that this capsule needs a car as input. So we might have specified input type to be car. And then here, we would receive an object called a detection node. And so we would be able to get the coordinates of this car, crop the frame, and run classification on that. But for now, I'm going to give you an example where we don't require an input. And I just very basically create a very simple capsule. So this is still none. And so what we need to give BrainFrame is we need to decide what we're going to feed BrainFrame after this. And so in the example on the slides, I return a detection node. So we're going to return a detection node here, and we're going to give it a name. So this will be called example, or we could call it a fake box. This is a fake bounding box, right? And so we need to give it some coordinates. So I already have some fake coordinates here that I put in the Google Slides. And you could give it a lot more information, right? You could specify attributes, for example, gender, male, right? You could append extra data to it, which has, detection, confidence, or something, right? But for this example, we're just going to make a box, and we're going to return it to BrainFrame. And so BrainFrame requires that this be inside of a list. So I'm going to put this detection node inside of a list. And so if we wanted to, we could return 2 boxes. And we could make this a little bit different than the other. But we're just going to make a single box, and we're going to return it to BrainFrame, and we'll see how that shows up on the client. So in this case, we no batch prediction is used. So we're just going to pass here. We're not doing anything. And we don't have any frameworks or models or things that need to be garbage collected. So we're just going to write down here. And I'll put a box there. And so now we need to fill in what our capsule returns. And so here we're going to specify that it returns a list. So it's going to return all of these fake boxes in the image because it's kind of a pretend detector. So here we say it's going to be an output type of all. And so all means that it's a list of objects. It's all of the objects of this type. And we're going to specify the name. And so this returns fake box type. And so now BrainFrame knows that it has a capsule called fake bounding box detector that doesn't need an input and that can provide fake box outputs. It knows how to load it by instantiating the backend here. And it knows that there are no options available for this capsule. So we have this directory here. What do we do now? How do we actually package this into a .cap, a capsule file? And so the way to do that is we're just going to have to restart the core server. And so you don't have to restart all of BrainFrame. You just have to restart the core. And so to do that, be in the same directory as your Docker Compose. And you can tell it restart core. And so core is the service that loads the capsules and that provides the REST API. So that's all we have to restart. And so you can see that it's restarting it. And as it restarts, we'll see this be loaded as a capsule. So we should see basic capsule.cap. Great. So we can actually see it there. So we know that that worked. We can see it's a file that got created. So this is going to be the contents of basic capsule. So let's see what happened on the client side. So I'm going to run the client here. Okay. So the server just restarted, and so I'm going to wait for the capsules to all load into. Oh, okay. So I believe that we had a crash on the server side. So this is where we would want to take a look more carefully to see if what kind of errors happened. So here we can see on the server side, okay, we can see that there was an error validating the capsule. So when BrainFrame loads the capsule, it does a lot of checking to make sure that the capsule is valid. And so in this case, it had a problem with me returning a class directly here as opposed to a function that returns a backend. So I'm going to fix that by just skipping this layer and making a function right here. And we'll instantiate the backend. So this is still the same thing. It's a function that returns a backend. And then I can go back to here and I can docker compose restart core. And so you can just do that. You can just restart the core as often as you'd like, and it will repackage the capsules. And so you can see that this was, one sec. Here under capsules, you can see this was last edited 9:59, so that just happened, right? The BrainFrame just finished repackaging this. And so we can kick open the client to see if the issue is fixed now. Great. And so you can actually see right here, fake box. And so if we click on global plugin configuration, you can see our fake bounding box detector. We can see that it's a fake detector that outputs a single bounding box. And so just to put these things side by side, so here's the name, right? And so that's coming from here. We can see the description. So it's fake bounding box that outputs bounding box detections. We can disable the bounding. We can disable the capsule, and you'll see that the box goes away. And we can re-enable the capsule, and you can see that the box comes back. And we can click on it, and we can see the description.